For example 7.4.5, we're considering calculating a sample size. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers aged 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers aged 50 plus who use text messaging on their cell phones? Let's identify information from the problem. Notice the question is asking us, how many customers should the company survey? This is how we know we're going to calculate a sample size. We want to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers. So we know we're doing a proportion. We have a 90% confidence level. And since we want the estimated proportion to be within 3 percentage points, this is our error bound, 0.03. Since our confidence level is 90%, we also get from that z alpha over 2, which is 1.645. We calculated that in a previous video, but if you need help doing it, remember that we're going back to that norm.s.inverse and putting in 0.05 for the probability to get out this value. Now we need to plug it into our formula. N is our sample size, z alpha over 2 squared p hat q hat over our error squared. We know z alpha over 2, 1.645. We don't have any estimated proportion p prime. We're not given any information. Well, it turns out that if we're not given a possible value to start with, then we pick 0.5 because if I multiply p prime and q prime together, both of them being 0.5, the result is the largest possible product of all numbers, of all pairs of numbers that add to be 1. So since nothing is known about our sample proportion, we're going to let p prime be 0.5, which automatically means q prime is 0.5. Now plugging in the rest of it, 0.5, don't forget your square on the 645, 0.5 over 0.03 squared. We can pull up our calculators. 1.645 squared times 0.5 times 0.5 divided by 0.03 squared will give us 751.67. 751.67 ... But no matter what decimal number we have, even if we had 751.0001, we always round up to the next highest whole number. So we round to 752. That's our minimum sample size that we need to have a 90% confidence that the proportion is within 3 percentage points of the true population proportion. If we get more than 752, that's great, but we need at a minimum 752 for these conditions.